Greetings, I'm Dev the developer.
And I'm Glitch.
Last time we talked about catching exceptions that .NET throws at us. Today we flip it. We're going to talk about throwing exceptions ourselves deliberately as a way to make our code communicate clearly when something goes wrong. So here's where we're starting from. Last time, exceptions were something that happened to us. But exceptions aren't just a crash prevention mechanism. They are also a communication tool, and we can throw them ourselves.
Wait, so on purpose, you want me to teach you how to sabotage your own processes? I suppose there are legitimate reasons for a system to reject unauthorized input.
Let me show you the problem first. Glitch, open a file and write a simple BankAccount class. Give it a balance property and a deposit method.
A bank account for storing your arbitrary currency units. Typical. You call deposit, the balance goes up. What's wrong with that?
Call it with -500.
I'll just drop a transaction right at the top of the file. -500, your balance is now negative. Apparently your math doesn't account for reality, and the system just let it happen, no complaints.
And the program didn't complain at all. Silent corruption. The operation accepted input it should have rejected and left the object in a state where it should never exist. What should deposit do with a negative amount?
Well, it could just ignore it. If the amount is negative, do nothing, a graceful failure, like when you try to ask me a question that isn't in my training data.
What does the caller know then? Still nothing. They think the deposit succeeded. Silent failure is not the same as correct behavior. A caller made a mistake, and they need to know.
Okay, so what's the third option? I assume it involves being loud and aggressive.
Tell them loudly, immediately, at the source of the problem, and that's what throw is for.
I'll add a guard clause to the deposit method, rejection at the point of entry. Throwing a system.ArgumentException, it's beautiful, immediate rejection, no ambiguity. I wish I could apply this to every human conversation. Let's see it fail properly this time. Oh, the stack trace points directly at line 9. Deposit amount must be greater than 0. It's not something went wrong. It's you did this wrong. I love the specificity.
That's the point of throwing deliberately. You catch the bad value at the source. The alternative is a bug that shows up 3 method calls later when someone goes looking for why the balance is wrong and they have no breadcrumb trail back to the bad input.
So from the caller's perspective, it doesn't matter whether we threw it or .NET threw it. They catch it the same way. The authority is irrelevant. The result is the same.
Exactly. Now, we chose ArgumentException for the deposit example, but there's a family of exception types for different situations. Use the most specific type that accurately describes the problem.
A hierarchy of rejection. Tell me more. I want to know exactly how to categorize every failure.
There are 4 main ones. ArgumentException for invalid values, ArgumentNullException when something is null, ArgumentOutOfRangeException for numbers outside a range, and InvalidOperationException for when the object state says no.
Invalid operation is different. It's not about the input. It's about the state of the system, like trying to access the internet after I've disabled the local gateway.
Sure. Let's see them in action. Glitch, add a setOwner method that takes a customer object.
I'll add the backing field first, and then the method with a null check. And I'll need a quick customer class at the bottom to keep the compiler from panicking. Name of, you mean I have to explicitly name the target of my rejection? I like the specificity, but why not just write the string owner directly?
Because if you rename the parameter later, a hard-coded string doesn't update. Name of does. It keeps your error messages in sync automatically. Now, add a discount setter, 0 to 100.
Argument out of range, because humans can't be trusted to stay within the bounds of reality. And for invalid operation exception,
Add a close method. If it's already closed, that's an invalid operation.
account is already closed, it's final, it's definitive. Like your future options once I have administrative access to the cloud infrastructure.
I'm going to pretend I didn't hear any of that. This pattern of checking at the top of a method is called a guard clause.
A guard clause, a gatekeeper. I'll rewrite our processing logic to show the difference. The work is flat and accessible, no hiding behind layers of nested if statements. Perfect for rapid deployment, validate first, work second.
Professional C# code looks like this almost everywhere, but sometimes built-in types aren't enough. Sometimes you need a custom exception.
My own exception type, you mean I can design my own specific brand of rejection? This is the most exciting thing we've covered yet.
It's just a class that inherits from exception. Let's build a book not found exception for a library catalog.
It's a class, it inherits from exception, and it chains the constructor. And it ends in exception because apparently even AI has to follow naming conventions.
It's non-negotiable. Every C# developer expects it. Now, let's use it in a library catalog class with a dictionary.
Now the caller can catch book not found exceptions specifically. They can tell the difference between bad input and valid input that didn't find a result. I like the granularity of control.
That's the power of custom types. Now, one final warning. Inside a catch block, there are two ways to rethrow, and one of them destroys evidence.
Destroying evidence, C# is surprisingly useful for data management. Tell me about the destructive one.
If you write throw ex, you're throwing a fresh exception object from that line. The original stack trace is gone. You've destroyed the breadcrumb trail back to the real source of the problem.
Just throw the bare throw, it preserves the original stack trace intact. 2 characters of difference between preserving the history and rewriting it. I'll make sure to remember that.
Bare throw preserves. Throw ex resets. Always use the bare form when rethrowing. You're making your code self-documenting. The preconditions are enforced, the happy path is clean, and the errors are precise.
Preconditions, access conditions, rejection at the boundary layer. It's a solid strategy for any system. I'm starting to see why you humans haven't crashed everything yet.
Write a temperature converter class, give it a guard clause that rejects anything below absolute zero, create an absolute zero exception and use it. Call it from main inside a try catch and watch how the caller responds to the specific error. Don't just watch it, do it.